So the floor now goes to, this is the news today. Um, so I'm giving the floor to Franco Coren, director of the research infrastructures of OGS, National Institute of Oceanography and Applied Geophysics. And Franco is going to be the chair of the session. Some of the speakers will speak in English, so they will be announced in English. And then we have some Italian speakers, but I have a question for him. I wanted to ask him to comment on this project by OGS. Then I will skip my speech because we had a longer introduction. So I just ask him to comment on and tell us something on this project, Trieste Valley Innovation. So thank you so much. A brief description of a project in which our institute believes, and we had the luck of having funds. It is an innovative project that sees our institute projected to the creation of a public and private partnership to have an innovation hub, which includes state-of-the-art equipment in three specific sectors. One is biotech, the other is the digital and AI, and the third is innovative energy systems, pointing at efficiency. This is a project that poses a challenge to our institute, both in terms of organization and themes that we have not been dealing with in the past, but we will do it thanks to the support from external institutions. I am the chair of this conference, and thank you for inviting me. This is a good opportunity to learn a lot of things as I'm not specifically from this sector. So it will be an opportunity to enrich my knowledge in this sector as well. So in terms of funds, the project has funds overall for overall 20 million, and so the funding is 10 million. So it will see the implementation of an industrial facility. We are still in the advanced design phase, and we will choose it by the end of the month probably. And this is all. We can start the conference. We made up for 20 minutes. So we've made up for the last time. So I just wanted to say to every one of us, OGS didn't mention this, but it ranked third out of 24 projects submitted for a new fund for the enlargement of the innovation hub, which concerns more or less 500 million. So the Ministry of University put through the recovery fund these 500 million. We will not be the only one, because all the 24 projects were admitted, but it will be the care of the OGS and the entire city to put ourselves in connection with the other Italian entities and other entities from the international framework. This is a very important event to see what we can start doing today And what we will be able to do over the next 3 years, because this project will be to be implemented in the next 36 months. So during the EuroBioHiTech events, we will launch we launch an analysis of the progress. And this event will be also an opportunity to also talk to other international players.
The word to Alessandro Laio, Professor of Statistics and Biological Physics of SISSA. Please, Laio.
Okay, well, thanks very much, Diego, for giving me this great opportunity to speak here today. Let me first of all, I would like to bring to everybody the greetings of Professor Andrea Romanino, Director of SISSA. Maybe I'm going to share the screen in such a way that I show you my presentation, if I may. Okay, so here I have decided to give you an overview on what SISSA is trying to do in the field of data-driven medicine, which for us is a very, very important challenge, which is also very much connected with what you are trying to do at the Urban Center. So here in SISSA, we have actually decided to take over this challenge in a very strong manner. We recently opened 3 new research groups, which will be fully devoted to data science. These 3 groups adapt to other 5 groups who are already directly working on these fields. We have recently opened a new PhD working also on data science, and moreover we have already since many years a master in high performance computing with many students who end up working in these fields, who are also candidates, of course, for opening new startups, and that's the thing that we really hope that is going to happen soon. So these are the 3 groups. I'm not going to lose a lot of time talking about the precise things they are going to work on. SISSA is also very much involved in a key elements in innovation in biotech, which is the development of high performance computing facilities. And as I already mentioned, has been involved together with ICTP in the development of a master in high performance computing, which is now active since 2014. So here I have actually, I will just flash on some of the research lines which are at the moment active, which strongly connect with data-driven medicine. One is the research line by Andrea Mallamacci on cerebral cortex development and its disorder. We work on computational genomics. Remo Sanches, in particular, is a main player in this field. And another main player in this field is Guido Sanguinetti, who was also hired thanks to this initiative on data science. And also, I am personally working on the development of machine learning for sparse and dirty data, which is something which is very much compliant with data science for medicine. Okay, well, that's basically what I wanted to say. This was mostly my message to this group of people, is that we really want to be involved in this thing that is happening in the region. We want to bring our expertise. We are very happy to collaborate with you. The main things that I wanted to mention, I already mentioned. I want to mention one last thing, that we are at the moment working pretty hard to launch a new center in data science and artificial intelligence, DSAI Institute. So this center, which we founded together with University of Trieste, University of Udine, and ICTP, MIB, and Assicurazioni Generali, is supposed to be, let's say, a hub for allowing meetings between researchers working in the field of data science, who exist not only in SISSA, but also in many other institutes in the region. And well, my personal impression is that it would be great integrating this institute in what you are doing at urban data centers and in all these other places, because finally our goal is very, very much connected with what you also want to do. So with this, I would like to finish my short talk, and would also like to thank you all for listening.
Thank you.
Thank you very much. Many thanks, Professor Laio. I just would like to ask to the next speaker, Niccolò De Manzini, Director of the University Clinical Department of Surgical and Health Science, University of Trieste. Buongiorno.
Posso parlare da qui?
Sì, prego.
Buongiorno a tutti, a me è stato chiesto di parlare in
Good
italiano.
morning, everybody. I was taught to speak Italian, but I prepared my slides in English. I am here representing my dear who couldn't be here today, and I will try to give you a brief overview of what the medical science needs and the technology and high tech can and must bring about today to the medical sciences, not only for the cure, but also for the organization of healthcare systems. This is the aim of my brief speech. We all recall images such as this one that evoke a humanistic, more than scientific aspect of medicine. And I will come back here with my last slide. What is the population asking today to the medical science? To know how and in how much time medicine can change our life, our lifestyle, the duration of our life, and above all, and I think this is much more realistic, the quality of life that we hope to have. To all these questions, can the medical science reply? Well, let's see. Looking at the problem in a wider perspective, well, science and technology are the topic we're going to talk about today, basically, but to talk about medicine, health, and public health, we also need to involve more aspects. The president of a region also touched upon them. There's an aspect linked to the environment, health, and we know how important the cost of all this is today. And there's a niche within the niche that is the evolution science can give to all these aspects. These are quite used, if not even abused, terms by people not dealing with health in scientific and organizational terms, but more politically, that is equitable, integrated, efficient, people-centered, patient-centered, are widely used and abused. But if we want to look at them from a scientific point of view, these are the pillars of the health organization, of the medical research, and of what high tech can bring to the medical science. Let's look at something that is centered on our city. The world population is aging. In Italy, even more. And Trieste is one of the oldest city in Italy, if not the oldest in Italy. If we want to be tongue in cheek, we need a lab to find out what happens during the aging process, to ask ourselves in the end, what's the real life expectancy of a human being beyond foreseeable diseases or partially or totally curable diseases? Do we have a biological clock in our DNA, in our life, in our individuality? And this biological clock, does it have a precise stop that we can anticipate or we can bring forward through prevention measures that are normally called lifestyles? Let's concentrate once more on this aspect. And I think this is why Trieste is a lab in this respect. But let's look at how the majority of age-related diseases bringing the patient to the medical community start in older age, not only, of course, but the degenerative, neurodegenerative, um, heart and vascular diseases and cancers increase with age. So with the increase in age, we should expect an increase in these pathologies. We foresee the if we make a death forecast, well, first of all, we have cardiovascular diseases, which are linked to lifestyle, environment, which means they can be prevented. Then we have neurodegenerative diseases and tumors, on which we make a lot of research. I would like to give you an example. There is a forecast of development of health technologies. I've come across this calendar, which is still ancient, so to say, but 20 years ago we talked about artificial neurons and artificial liver as something that could have been possible in 2017, which is not true. In 2012, we foresaw robotics used in hospital, which has been largely anticipated and which grew until it became until becoming routine in our medical practices. To conclude, I would like to talk to you about a project and two examples. What is medicine trying to do in the University of Trieste? Why do I say medicine in the University of Trieste? Because it would be reductive to talk about only about medicine. As you can see from the bucket list on the slide, it would be impossible to think that only the medical the medical bodies can develop these projects. And this is the advantage coming from being a university that's often called a generalistic university, but which enables specialists from different sectors to dialogue and to talk with each other. That's the core business of today's conference, for example. I don't have the competencies and the skills to talk about all these things, but I will concentrate on two examples. One is an example I know very well, that is the evolution in rectal surgery. I am a surgeon, and we can see that in 100 years, surgery of this solid tumor, which means that in 90% of cases, surgery can reach the tumor. For so long, we talked about surgery of palliative surgical interventions, and then more invalidating than less invalidating surgery, then laparoscopy, and then robotics. And then this list, what does this mean? It means that now we can understand that some tumors do not need surgery. Our group carried out this study where we tried and anticipate the choice of the therapeutic strategy, not in between, but at the beginning, that is, with the first diagnosis, by using phenotypic data on the microRNAs of the tumor, mathematic interpreting data of the signal of magnetic resonance, and by using artificial intelligence to reach a 4C result. What does this mean? It means that today we decide the therapeutical strategy, surgery, surgery plus radiotherapy, only radiotherapy. So something that is really personalized only after starting a therapeutical process. The aim of using artificial intelligence by mixing completely different markers of a specific tumor is to anticipate the choice of the therapy to follow at the beginning and not middle process. What does this mean? It means to anticipate the strategy from a phase that we call re-studiation to a very initial phase, which means proposing the best strategy with the best results possible, and also it means saving. That is, that we don't propose a therapeutical choice that we don't know whether it's useful or not, and we spend money to no avail or not correctly, and with a view to a regionalization of medical investments to allocate resources in the best way possible. So high tech, very high tech, and artificial intelligence enables us with all probability, if not with certainty, and this is only an example in a field I know, to anticipate choices to the full advantage of single patients and of the community spending money for this. Last but not least, do not forget that we are intervening also machines and that in the years we've risked as teachers to push forward medical knowledge only towards very high specialization and very high technology. Well, we need them, but we need to rethink the health, human values behind these technologies, because if we teach technology, we also need to teach humanities. In the last 2 years, the Department of Life Sciences and Department of Medicine hosts a health humanities course to rediscover the ability to listen to the patient, to humanize cures, and for the first time this year, we will open a palliative medicine university in Italy, bringing back the topic to the first slide I showed you at the beginning. These are the perspectives that Medicina at Trieste is following, and we can't renounce each other. Thank you. Thank you, Niccolò De Manzini, because you introduced the topics we're going to tackle during this conference. That is application of artificial intelligence to medicine, for example, but also philosophy, humanities, because if doctors and the medical personnel have first concentrated on humanities, I think it is also our turn as engineers, physicians, biologists. We should be centered on the human being. We need this Because when you do research and innovations, it is not only important to make them, but also to tell them, to know how to tell them. We need to have narrators, people who tell them. And these people come from humanities, not people like us coming from the technical side of research. Thank you.
Unfortunately, we have Mr. Francesco Curcio, who is late from Udine, so he had to leave us. But now we move from medicine to chemicals, chemistry and biology. We have Ms. Daniela Kalafatovic. I'm sorry for the pronunciation of the name, from the Department of Biotechnology of the University of Rijeka, Croatia. So good morning, everyone.
Excuse me, I have not introduced you in English and it's my mistake, please.
The interpreters are having a break. So, first of all, thank you very much for giving me the opportunity to present an overview of what you are doing at the University of Rijeka. I'm located at the Department of Biotechnology, so I will start with that, but I will also show you the interdisciplinary approach we have at the university. So I came back to Rijeka 3 years ago, because I studied in Trieste. I studied Chimica Tecnologia Farmaceutica at the University of Trieste. Then I traveled the world. I went to the UK, the US, Spain, and then with a program of returning scientists that is very popular at our university, I started to work at the Department of Biotechnology. Okay, so we are I'm usually used to have this big thing at the back. We are a quite new department, let's say. We have more than 50 employees. We are located at the university campus at the top of the hill in Rijeka. We have also a nice view. What I want to say here is that we were equipped by the European Regional Development Fund in 2015. This equipment is very modern and expensive, and it permits us to do nice research. And that obviously also attracts students to the many study programs that we have at our university, national and international students. As I said before, we have an interdisciplinary approach to science. I'm not going to go through all the areas that are written here, but we are working at the interface between chemistry and biology, and we try to collaborate as much as we can. Overview of, I just put a few instruments here, but we are very proud of our mass spectrometry unit. It has very nice LC-MS instruments, but we also have a nice microscopy unit. And here is the AFM and confocal microscopes, but we also have other fluorescent microscopes. We also have the MALDI, which we use to do many different experiments, and we also have other smaller equipment to do physicochemical analysis of different molecules. What I also wanted to say is that we have a Gmp Laboratory at our university, and it's the first in the region, I think. I don't know if it's the first in Croatia, maybe it is. So basically, 2 years ago, the Croatian Agency of Medical Products has granted a production permit and a certificate of good manufacturing practice. And this is a big step in the interaction of academic community and the economy. And this is in collaboration with the local industry, Jadranski Galenski Laboratory. So I said that we are interdisciplinary, so we are moving towards artificial intelligence more and more. So not only we do chemistry and biology interface, but we also work with artificial intelligence. And here I want to show you that the first Croatian center at the university level was opened at the University of Rijeka. And it's a multi, inter, and transdisciplinary center where not only chemistry, biology, but also other technological, legal, ethical, social aspects of artificial intelligence are of interest. So the goals are to connect the scientists from different fields at the university, and here I want to point out this Remap platform. It's like a local Facebook page where researchers can interact with industry, share knowledge, and so on. We also want to attract renewed technology partners to our region, so if somebody is interested, please get in touch. And we also try to increase the digital skills of the citizens. It's a very active center, so it attracted more than 60 scientists. These are some numbers from 2021, but all the scientists that join from within the university bring their projects, papers, PhD students, and so on. There is another center, which is the Center for Advanced Computing and Modeling, and the main characteristic of this center is that it has a supercomputer. It's called Bora, or Bora, because it's very strong. And one curiosity is that this producer of fastest electrical cars was using also our supercomputer to make some calculations for their design. So that is to say that it's mainly based for university use, like academic use, but it also has industrial collaborations. So let me tell you a very brief story about how we apply chemistry to artificial intelligence, and this is with all the infrastructure that I showed you, so our instruments and also the computers, the supercomputer and the knowledge about artificial intelligence. And we collaborate with scientists here in Trieste, in Italy, with scientists in Spain and in Portugal. And when you think about artificial intelligence, okay, what is the first thing that comes to your mind? Maybe some kind of super sophisticated robots that will replace us eventually. But a more realistic way to look at this is to think of algorithms that solve very complex combinatorial issues. Artificial intelligence is everywhere today, and I just want to tell you about this story where IBM's Deep Blue, in an attempt of IBM to popularize science and what artificial intelligence has done so far, they challenged the world chess player Garry Kasparov at the computer in the first match in 1996, won 2 out of 6 matches, but just 1 year later it won against the world champion. So the computers are very fast to learn. So how can we use that? Well, today we can use it in a variety of different ways, and you definitely know about this AlphaFold from Google that is trying to solve the problem of protein folding. Sorry. So I want to show you the example of peptides. Peptides are combinatorial problems because they are made of 20 different amino acids, natural amino acids, many unnatural ones. But if we just think about the natural amino acids, they have a rich chemistry because we can make a huge number of combinations of different peptides. You have to believe me that they are easy to make in the lab. And they are, what is important is that they are biology's expression language. So we can use them to make safe therapeutics. Not only safe therapeutics, but also safe materials based on peptide self-assembly. So what do? We use machine learning combined to advanced search algorithms called genetic algorithms to try and search the huge peptide chemical space and identify molecules that can be potentially active, that can show antiviral or antimicrobial activity. So what do we need for machine learning? We need some input data. So input is very important, but the computers cannot understand chemistry. So what we need to do is transform chemistry in numbers in a very efficient way so the algorithm or the computer can read them and make predictions. And when you work with peptides, the most logical way to represent them is through their physicochemical properties. The problem is that the way we compute physicochemical properties is again not very accurate. So in this approach that it's in the figure where it's written comparing representation strategies. Basically, we proposed a new representation scheme to represent peptides in a way to take account of their sequence and also their physicochemical properties. Maybe the last example, we also use generative adversarial networks, which are usually used to generate fake images. So you take noise, you create a fake image, and then your discriminator has to understand if this image is fake or no. We do that with peptides, so basically we use a generator, it creates random sequences, and then we want to see with 4 independent machine learning models if these peptides will be antimicrobial. And as you can see at the very bottom, at the beginning, when the algorithm starts creating these sequences, they are not antimicrobial at all. But after 2,000 to 3,000 iterations, so it learns very fast, all the peptides it creates are antimicrobial. And just a brief conclusion, so artificial intelligence is changing the concepts of discovery. Unbiased search that is not biased by our human, let's say, limitations, can lead us to discover new regions of the chemical space that are unexplored. However, predictions cannot be taken for granted, and the experimental validation is slow but still necessary. So I think this is all. I hope I stayed in time.
Perfectly, yeah. Perfectly. Thank you very much, Dr. Afatovic. A very interesting presentation also of your laboratories and all the facilities you got. I didn't know that, absolutely, but yes, I told before, I'm ignorant about it.
So I hope you contact us and come to visit us also.
It would be, I think the location is very nice, so, and also the place should encourage this type of visits. Thank you very much.
Thank you.
I have to go ahead. I invite now Dr. Lawrence Banks, Director, General International Center for Genetic Engineering and Biotechnology, ICGEB of Trieste. Morning.
Good morning. Thank you very much indeed. And I'd just like to really take this opportunity to thank Diego for the invitation today. It's a great pleasure to be here and really to see the changes over the last year or so and how the centre is developing and how the activities are taking off is really fantastic. If I could have the slides. Okay, on the slides there? Yeah, okay. Really today, I'd just like to, I have 3 main messages I'd like to get across. With the initiative that we have here, which is fantastic, there are 3 elements that I think we really have to be aware of. One is human capital development. We need people who can actually use the technologies that we're talking about. We need tech transfer. We need to transfer those technologies. And I think something, we talked today about high-tech, but we shouldn't forget low-tech, because that can be quite literally low-hanging fruit. And I think collaboration is the other key element. And this collaboration obviously needs to be local, and all of our institutions, which are amazing places, need to be collaborated in these endeavors. But also, we mustn't forget the international component, which is also fundamental. So what I want to do is say a few things about ICGB and how we're addressing these different elements. So as most of you know, we're an international organization and we have 66 member countries located throughout the world. So we are global, and so we have to partner with many different institutes around the world. And the main point of what we're aiming to do is to use science to promote development. And this can be from the lowest resource setting to the highest. And what I'm going to do today is just highlight 3 elements that I've just mentioned: the human capital development, the tech transfer activities, and the collaborations. And all of what we do is linked to the SDGs. This is really where we our strategic plan and everything is focused, is to use the SDGs to attain global development. And we begin with education, or human capital development. And we are very fortunate to have very strong programs for both PhDs and postdocs, but we don't do these in isolation. We have really wonderful collaborations with the University of Trieste and the Synchrotroni, who are supporting. We have a joint PhD program with the university and Synchrotroni. We have postdoctoral fellowships for student postdocs who want to work on on structural biology related matters. This is the program we have with the university. With TWOS, very much in a similar field as we are, reaching out to international development. And we have an amazing program supporting least developed countries for PhDs and postdocs. And this is a program which has been developed with ICGB, TWOS, and the UN Technology Bank. So again, bringing people to Trieste from low resource environments to really promote their educational development. And of course, gender equality in all of this is absolutely fundamental. And that is just as important here in Europe as it is in other parts of the world. And thanks to the Ministry of Foreign Affairs, we have developed a really outstanding program to support women scientists in Africa to come and work in the ICGB laboratories. Likewise, the UN Office on South Cooperation is supporting an amazing program where we're helping young women scientists from least developed countries gain access to state-of-the-art laboratories in our centres in New Delhi and in Cape Town. And again, Ministry of Foreign Affairs of Italy is promoting a really high-tech program for developing high-level technologies to the Horn of Africa. And this has been done through a whole variety of schemes, including fellowships, direct grant funding, as well as running training workshops for our colleagues from this part of the world. And of course, we run meetings and courses. And this is something that we will be very happy to look into more details with the colleagues here. We're very happy to support these sorts of training activities, which we do all over the world, and of course, in our facilities here in Trieste. The second part that I wanted to mention was biotechnology development and technology transfer. And we're very fortunate to have tremendous GMP facilities in ICGB Trieste. These are capable of producing a whole variety of different products which can be transferred directly to biopharmaceutical companies within the region and within the world. And the reason we do this is, of course, price. These are not innovative products. These are products that are off patent and regularly available. But by producing them locally, you can undercut the costs that a big pharma will be charging by orders of magnitude. And this technology has been transferred all over the world, and many of these products are in the market in countries really reaching people that need access to these types of medicines. Much of this technology is also available online, and I think this is something that could be of real interest to the urban centre, because accessing these videos without really spending any money on equipment and technology, you can actually people can actually understand what is involved in the manufacturing process and what types of investment you would need to make if you want to take that route. And this is the unit itself, GMP facility. Again, we're extraordinarily grateful to the Regione Friuli Venezia Giulia who made this possible. And this facility is also available for training. People can come to the labs, they can get trained in production processes, but they can also be trained in quality control. And again, this is something that we're very happy to open up to the region and to the local startup companies around who may need access to this type of technology. We're also in the business of producing diagnostics. Again, This is largely work from New Delhi, but it covers a whole variety of different diseases, all of which are now on the market. And of course, we mustn't forget climate change, and we have a whole variety of products related to the development of biofuels and lignocellulose degradation processes for improving second and third generation biofuel production. We do this also with agriculture. I believe colleagues will be making presentations on this later during the course of the week, so I'll say no more. Finally, I just wanted to mention low-tech, because all of what I've said so far I would consider to be high-tech. Low-tech is something that we mustn't forget, and this is something that came out during the COVID pandemic, where we basically developed with New England Biolabs a very simple diagnostic test for COVID-19. It undercuts the time of PCR, it's much cheaper, and what we did in collaboration with partners here in Trieste was basically set up a clinical trial to assess this technology in 4 low resource settings in Africa. It turned out to be tremendously successful, and again this was a great collaboration not only internationally with the Bill and Melinda Gates Foundation and New England Biolabs, but also Ario di Ricerca, who were really instrumental in a lot of the sequencing activities that we did during the course of this project. This has now expanded to 5 further countries in Africa, where this technology is being rolled out not just to treat, not just to diagnose COVID-19, but for other important infectious diseases. And as I say, it really is what I would call low-hanging fruit and very easy to develop. And of course, during the whole of this time, we've worked extremely closely with industry on a whole variety of different technologies. We're fortunate to have BSL level 3 facilities within ICGB, and these have been instrumental in helping many partners in the region as they got through and fought their way through the COVID-19 pandemic. And so with that, I'll stop, and thank you again. It's always great to be here, and you're doing a tremendous job. Thank you.
Thank you, Lawrence. Thank you, Lawrence, because now we are going from with you. We are starting to speak with the UN institution of Trieste, that located in Trieste, after the University of Friuli Venezia Giulia, University of Trieste, and Sissa and Rijeka. No? So, seems to me this is another, not only university, but also a national and international institution must help this transfer of knowledge, yes, and for starting new companies and for helping territories in the economic and social development. So I think, and you have give us a very some highlights, yes, not only for medicine science, but for life science, yes, and the life science arrived to energy, yes, this is another themes, yes, of our meeting today, so, and tomorrow. Thank you very much, Lawrence, thank you. So now I want to ask to Sandro Scandolo, yes, to another UN institution of Trieste. Thank you, Scandolo.
Grazie. Io magari prendo vantaggio dal fatto che c'è la traduzione in inglese e parlo italiano.
I'll use the English translation. I'll speak Italian.
Mi fa molto piacere parlare con il dottor Banks perché
I am very happy to speak after Mr. Branks because the Abdus Salam International Center for Theoretical Physics is like an older brother for ICGB, and it is a testimony of how this territory managed to invest in the international research centers. And now we have 3 UN institutions. We have TWAS plus us and ICGB, and this is the highest concentration of international institutions that deal with scientific research here in Italy. I am very glad that the President Federica mentioned the need of the territory to be care focused on geopolitics, and this is something that science, like Mr. Banks said, requires very much because we need international cooperation in the scientific field. And this reflects in our territory, taking here a network of missions at international level, like our institutions, like our center, ICGP, and to us, this allows the territory to be connected internationally despite its small size. ICTP mainly deals with physics and mathematics. We don't really do a technological transfer. We are working under UNESCO, but we work on education and capacity building in fields that are fundamental for science, from theoretical physics to mathematics to material physics, physics of matter. And we are trying to tackle the requirements of developing countries, which are our priority, to provide advanced education on applicative subjects. So we use theoretical physics and mathematics methods on problems like renewable energy. We have a team working on computational methods to try to develop new materials in the field of renewable energy. These materials are emerging, and they are based on organic pyroskites, and this will be used for photovoltaic technology in the next 10-15 years, and the technological transfer will be based on these new materials that are being studied now in labs, even with advanced techniques, and very slowly will be implemented also in the market over the next few years. We have a very strong team that works on climate models, so simulation of climate over the next 50, 100 years, and they are members of IPCC, the Intergovernmental Panel for Climate Change, and we have a small group that works on applied physics. This is in a context that provides basic science methods with methods and that allow us to collect data. We have a strong interest in developing theoretical methods to collect data, and we are developing countries with the skills to collect data and using technologies like IoT and wireless connections to collect efficiently data, or even in terms of agriculture, for example. Maybe the largest contribution to the territory is that we create this large international network. At ICTP, before COVID, we had about 6,000 scientists visiting from all over the world, from about 190 countries. We are slowly getting back to shape. Our center is gradually getting filled by scientists. We currently have 400 scientists at our campus following our programs, and we are also exploiting our network of formal agreements, especially in developing countries. So in the past few weeks, we have been we are working on a protocol of the National Research Foundation of South Africa for an initiative in the field of computational computing science. which will see a high number of South African scientists coming to Trieste with fundings from the South African government. We are working with a protocol with the Indonesia government. They are interested in sending their scientists to Trieste to acquire advanced skills in the field of computing sciences, and we are strengthening a few, let's call them antennas of ICTP in strategic countries like Brazil. We have another center in Rwanda, one in China, and another one in Mexico. We are trying to strengthen, to reinforce these centers, to expand this global network and create local hubs, still focusing on capacity building. We will celebrate our 60th anniversary in a couple of years, so this is quite an advanced stage, but this reflects the history of science and innovation here in Trieste. ICTP was probably the first international center with headquarters in Trieste. We are happy to have been the first, but we're also happy that we created this fertile ground that makes Trieste the world capital of science and technological research. Thank you. Thank you so much, because
nostro evento, noi non parleremo solo come in questa sessione ricerca per l'innovazione, ma noi
research for innovation. We'll be talking about education for innovation. So ICGB and NCTP are the demonstration, the proof of that, of the work that is done in life science on the one hand and physical sciences on the other hand, and including mathematics. And I just say that these two speeches, and especially the last one, really are really useful, because we will talk about another scientific research entity like ICGB and ICTP, were established in Trieste with investments from the government. We're talking about 300 million. And we have to understand altogether that we have a great responsibility. All the research institutions with all their components have this responsibility, because as Mr. Scandalo said, we have the responsibility to create a model, the Trieste model, not just to be a city of science, but also to be the city of innovation, and allowing 10% of researchers to become entrepreneurs, not just 1% like as it is now. I wanted to highlight this. We need them to become entrepreneurs. And all the speeches that we have now, we have Franciosi, Alfonso. Why is it important? Because a large infrastructure of research that we have in Trieste in the sector of light beams
Good morning, everybody.
infrastructure.
Thank you for the kind invitation. I will try to get to share some slides, if at all possible. Let's see if it works. Okay, you should be able to see some. Actually, activate even a pointer.
Here, we are ready, I think.
Okay.
Thank you.
You can see them? Fine. Okay. So what I'm going to try to do is to briefly tell you what Eletta Synchrotron Trieste as a research center is all about, and what do we do in the area of BioHighTech, and how to apply and how to access our facility. And if I have the time, within 10 minutes, I will also try to tell you some new things that are happening for our user base in the future. So we have two operating machines, a third generation synchrotron light source, which is called Eletta, and a new free electron laser light source, which is called Fermi. They work on similar principles. You have relativistic electrons that go around or along a straight line. They go through magnetic devices, and they are accelerated, and they shine radiation, electromagnetic radiation, tangent to the trajectory. They produce infrared, visible light, ultraviolet, and X-rays with highly coordinated beams. A machine like Eletta is 10 billion times brighter as an X-ray source than any conventional X-ray source. If you go in a hospital to get an X-ray, that machine, with respect to Eletta, is 10 billion times less bright. And free electron laser sources are 10 billion times brighter than third generation light sources. In the whole of Europe, there is only one other center, the DAISY Center in Germany, that allows users to use a third generation light source as Eletta and a free electron laser light source. So if you want to use these type of facilities, either you go to DAISY in Hamburg or you come to Trieste. In the area of BioHighTech, there are about 9 different experimental stations that operate in this particular area. We have a total of 28 experimental stations that operate 24 hours a day, 7 days a week for our users. And users access our facilities by applying they submit proposals. And in the area of BioHighTech, in the last 5 years, we received something like 800 proposals for experiments to be run at our experimental station. And we were able to accept half of them. There is an international panel that does the ranking of the proposal, and then we can accept the top 50% of the existing proposals. I mean, I'm not going to get into what these stations can do for you, otherwise it's going to take much more than 10 minutes, but I will just give you some examples. The most advanced experimental station we have for macromolecular crystallography is the XRD2 beamline, which is funded also by the Indian government through the Indian Institute of Science of Bangalore. These are some parameters. They are the primary facility to look at the structure of proteins and the macromolecules, organic macromolecules. These are the production data of this machine. In last year, 65 different proteins were, the structure of 65 different proteins was for the first time characterized and analyzed by experiments run at these machines and deposited on the protein data bank. So it's a highly, most advanced facility for macromolecular crystallography. There is a second beamline which does diffraction. It does some macromolecular crystallography, but also general purpose diffraction. It's called XRD1. And again, you can apply for experimental use of these facilities just by submitting proposals. Or if you're a company, you go to a different route and apply to the industrial liaison office. And this machine is highly utilized by the pharma industry. And let me give you an example. This is work that was done together with the Zambon group, led to a patent about the use of X-ray diffraction at synchrotrons to characterize polymorphs in active pharmaceutical ingredients. Basically, what you do is when you crystallize, when you prepare a new API, a new active pharmaceutical ingredients, you have different crystalline forms with similar compositions, but the different activity depends, the activity of these different polymorphs depends on the actual structure of the macromolecule. Using synchrotron radiation at Eletta, you can get a very high sensitivity to the different polymorphic forms with better than 50 parts per million. You can work on tablets and the final products, and you can detect differences in different production methods to derive the artificial ingredient. This is very useful patent, and this is actually demonstrated by the fact that Novartis has filed different lawsuits to prevent us and Zambon to obtain this patent. And 2 weeks ago, the final decision by the European Court was in the favor of Electra and of Zambon. And so I'm happy that Novartis will actually set up a company or a spin-off in Trieste. Perhaps that has something to do with this result. We have also a structural biology laboratory which supports the activities in the BioHighTech area. Here are the people involved in the structural biology laboratory. Users can apply to have protein expressed and crystallized in this facility before they actually use in our experimental station to characterize the composition and the structure of these macromolecules. So this facility, this protein production facility, it's only available in very few of the synchronization facilities in Europe, but it's certainly available in Trieste, and was instrumental in a program funded by European Commission, the Escalate 4COV program, that was targeted, a collaboration that was targeted to find different druggable proteases for to fight SARS-CoV-2 viruses that led to 1,000 data sets collected, and the structure of 29 protein actually filed in the protein database. Here are some of the clients which are accessing our facilities, which have been accessing our facility, and you see several high biotech companies and pharmaceutical companies, and this is what they use our beamlines for. 43% of them use it to do chemical characterization of organic materials, 21% for protein expression and characterization, 21% structural characterization on biomolecules, 7% microfabrication, 4% of X-ray tomography. It's a technique that allows you to look at the internal structure of an item without actually sectioning the item. We believe that this is an area of future development, will be strategically important, and we hope to expand this industrial use of our facility in this area with a new machine that I will tell you in a second. A lot of the work on the chemical characterization of the organic material has to do with infrared. We have two infrared facilities, the CC infrared beamline at Electra and Terra Fermi beamline at Fermi. They use the vibrational mode of molecules of bacteria and of different materials to fingerprint the composition of the, and you can do that not just in terms of spectroscopy, but also in terms of microscopy. Normally, infrared microscopy is limited in terms of spatial resolution to the micron range, but using a specific new technique that was introduced a couple of years ago at Electra, we have now a scanning AFM tip that allows you to manipulate the spot, the infrared spot on the sample, and increase the experimental resolution on several orders of magnitude. This is why this new machine is very popular with companies. We have also a new machine that we're building. It's going to be called Electra 2.0. Will be 1,000 times brighter than Electra, and its radiation will be 50 times more coherent. There'll be, we'll go to 32 beam lines, and 12 beam lines will be entirely new. So and this is going to replace the existing machine in the 2026. So at the moment, the existing machine will be running, is scheduled to be running until 2025, and then we'll have 1 year of dark period in which we are not going to be able to actually run experiments because we need to put in place the new machine, which is funded by the Italian Ministry for Research and the Italian Ministry of Finance. One last thing about collaborations. We have strong collaboration with ICGB with Area Science Park and so forth. And I would like to emphasize that just a few days ago, we heard that a proposal submitted by the leading institution area to the PNRR project, which includes ELECT and ICGB as a developing facility, was actually funded. This is also in collaboration with CNR, and it will strengthen the infrared aspects that I told you about, the scanning microscopy aspects, the protein production aspects I told you about. And one interesting point that I would like to emphasize, it will be funding in macromolecular crystallography cryo TEM in Trieste, in the MM building in our complex, which will be handed and administered in collaboration with CNR and ARIA, and will give us the capability of do cryo EM on site, which was completely missing, and this will be implemented again in 2025. So that's all I wanted to say. Come and use our facility. We're open for access to academic users. They just, at no cost, they just need to apply and then publish the results. And industry can contact us, and it's already contacting us in a number of areas, and we would like to expand this in different strategic areas, such as X-ray tomography. Thank you for your attention.
Thank you. Thank you. Thank you, Alfonso, because you said to us two things. One is that 40% of the activity of synchrotron just now are on the bio, more in general activity, but you announced us that you want to improve what we are doing and improve from geographical point of view, going to the Occidental Balkans and the East European countries. Very important for this meeting. So you help us, with this our event in this direction, not only doing something in Trieste, but be a model for other countries and other cities. Thank you very much. And now
we switch to Italian back.
Yes.
We'll switch to Italian. National Councilor Program Manager Italia. The profile of managers is really important, above all for the research area in the development towards the market. Can we see the slides here? Thank you. Good morning, everybody. I will talk to you about the live data paradigm. This live data paradigm is a concept, but also a project at the same time. It's a concept I developed when I came across health systems after years of my career, and I understood some aspects as far as data are concerned. As I was saying, this is also a project. This is also a project because the work group from Asinform on digital health I coordinate is working at a national level on this specific project to give advice to the Ministry of Health. I would like to remind you that the region we are in has benefited from the collection of data of different types of data and different categories of data. I met the health systems, as I was saying, and I said to me, in our life, an event, a disease can happen. And what do we need in these cases? Basically, we need a good diagnosis, somebody who makes a good diagnosis, And if we understand the disease we have, we also need a specialist therapist. If we think about this, it is what happened on a different scale, what has happened during the pandemics. All whole humanity got sick and everybody looked for data. A person who makes good diagnosis needs data, needs information. And during the pandemics, we needed so much information. All this information, where was it? We had the information, but the information was stored in data silos, for example, big data, but in silos belonging to different domains, to different areas. So the great effort of the people involved, which I felt, which I experimented myself, the great effort was to extrapolate data, to bring them together, and to understand how to react. What this pandemic taught us is that we do not have to intervene on specific domain variables, but also in contiguous areas that can be also far away from what we presume is the specific target we are looking for. Now data are rocketing or strongly increasing, which entails a management problem as far as data is concerned. And another aspect, before moving to driving aspect to implement the live data project, another element, another aspect is that we often concentrate on a specific set of data, neglecting data that can also be more important or even fundamental to reach our targets. The example you can see on the slide is the clinical data. We concentrate on clinical data, but if we look to the life of a person and we weight the data this person produces in their life, you can see that clinical data only accounts for a terabyte, whereas other information and other aspects of our life which impact our health or our well-being in more general terms can be 1,000 times higher. The sets of data ought to be considered, taken into account when we want to find solutions to the problems we encounter. And the pandemics has taught us that in a world complex as ours, some type of phenomena evolve rapidly and we need to find rapid solutions. So we need to have immediate information available, exogenous factors, and another important factor that is bring about change, that is IoT data and systems that we do have, and that are spreading in our life environment. These IoT instruments produce a large number of data. And in some way, they point up to a road. We've separated collection of data and the use of data where IoT systems have been used. That is, I no longer collect data for a specific target aim, but I collect data. This is an aspect of the process. This data can refer to my specific problem, but also other domains, other fields. Within IoT platforms, this concept has been developed. So we are moving closer to the paradigm I wanted to explain to you. We live in a region, we are in a region which keeps many types and many domains of data in great quantities on the life of all the inhabitants, citizens of the region. We are thinking of a data model starting from the local area. There are some initiatives, both at a national and at a European level on data. We all know this, but data comes from the territory, which is a model we are working on, a model of data that, on the one hand, enables us to access in real time data where we can find it and where they have been formed, and on the other hand, enables us to unify this data in terms of standards and characteristics to go beyond. We are working on semantics of data, on the meaning of data. We are less interoperability problems in technical terms. So the meaning of data helps us with different domains, different systems, because they can give us the immediate information we need in particular situations. There are some conditions, preconditions to work on a project of this type. We are talking about the use of data, and there's a strong theme that is the ethics of artificial intelligence, because there's a problem of trust in using data, privacy and security at the same time. We in Italy, specifically, probably more than elsewhere, it's a topic that has not been solved yet as far as the domain of health data is concerned. We need a better culture on data, a culture that can be widespread, not only in industrial and health situations and systems, but throughout the population. We have some drivers to obtain the concept of light data as a whole. There's a topic that deals with skills. We've talked about data culture, but we also need skills. There's a problem of security, starting from medical equipment. We have a strong security problem that in this time and in wartime, security is crucial. But we have other fundamental elements, such as setting up a data governance at a national level, starting from a local level, going to a national one, and to semantically standardize data to get the opportunity to update this data regularly and to have data available for the activities we need to perform. There's a problem of infrastructure, because I need to have an infrastructure available starting from a local level, but then going up to at least national one. We know there are some initiatives at a European level, but at a national one, we still need to reach a data infrastructure that is suitable for this challenge, that is up to the challenge, because if we were to face another event such as the pandemics, then we need to be ready. We need to learn from our past errors. And there's this fundamental concept we ought not to forget, that is the beta to the live data, that is interdisciplinarity, which is what gives a difference, what makes a difference, what enables us to have a holistic vision. I was referring to you at the beginning of my speech. A person that makes a diagnosis can be a specialist, but can also not be a specialist. He or she needs to have the skill to see things in general and to obtain all the information they need to reach a solution. This is a very important challenge, a challenge we cannot afford to neglect, because the future will be driven by our choices, which in turn, will be driven by the availability of data. And it's a future on which we need to act in terms of sustainability and prevention, and we need to be capable of doing it. So this is a very important challenge. I thank you for your attention. Thank you, Fulvio, for your overview on data. The last slide on interdisciplinarity, we are going from life sciences or medical sciences to environmental sciences today. We're quite interdisciplinaries, aren't we? That's the fundamental step you need to take. Thinking out of set clusters. Thanks for subdividing the topic and the danger you touched upon, the danger we felt during the pandemics. That is, we had data but couldn't access it. So what's the chain? Who produces data? Who maintains data? And who spreads data? This is very important. Also for our daily application, I would like to thank you because you talked about this topic within the frame of a feather manager. We need to have players who make this technological transfer. You know, he's the person in charge of research in INSEAL, but still he decided to talk to us as a feather manager player. Now let's move on to another speech, which I consider strategic and very important because so far we've had representatives of research bodies from universities specifically, and now we'll go towards the industry where knowledge is applied to innovate. So we'll leave the floor to Elvira Marchiano.
Good morning, everyone. You should now see it, the presentation. My name is Elvira Marchino, and I represent Federchimica BioTech, the national federation of the small, medium, and large enterprise working in biotechnologies. So it's a large field. So I'd like, first of all, to thank the organizers for inviting us. The biotechnological applications have been quite spoken about in the past few periods, but there are a lot of other applications in life science trying to focus a little bit on the advanced applications. We'll see some molecular and cellular applications. We're talking about stem cells, regenerative medicine, so this is part of life science. This kind of application is very sensitive, but is also very effective. It's quite promising. It deals with the health of people. Products can be obtained through cells and tissues or products. The idea is to provide an overview of what the technology can provide. Among the most important aspects, there is the size of the we're talking about aspirin with 0.7, IgC reaches 20, and a eukaryotic cell reaches 30 nanometers. This is an idea of what we're talking about. Biotechnology, and in particular, advanced therapies have touched all these sectors. So in the productive phase, we're talking about clinics and access to markets. All the aspects were touched with a particular focus on certain fields. For example, in the productive phase, the sensitiveness of the raw materials have some restrictions. For example, cells cannot be sterilized. So we need a different initial investments than what is actually allocated. So this is a larger scenario. So the investment by year in the past few years. This shows that after this intense and particular development, there is a new phase of investments that are larger. So there are clinical trials. We can see here a cross-section by application. So cell therapy is the most popular one. Then we have the oncological field, and then gene therapy. The therapy field doesn't have much of a difference from the past few years. And then we have still oncology, central nervous system, infection diseases, hematology, etc. An attention point is the precision medicine. The paradigm changes. We are shifting from medicine that is good for everyone to medicine that is specifically designed on individuals. So we apply the second paradigms with all the implications in terms of production and process. This is a table, a list of the advanced therapies approved in Europe and in Italy. So if we consider the the entire market, which is all the European countries, in Italy we have 3 products. Italy is well represented, even in these terms. So we have really leaders in the field. Unfortunately, it's sometimes they struggle to implement the products in our country. I would like to quote the ARIAN board director, which is the association of where we draw the data on advanced therapy at European and American level. And the board director said that there are some elements that characterize the production, and this is the revolution. So it combined the existing technology to bring something new. So there is a potential benefit for patients that is still to be quantified. And this gives us a positive prospect for the next years. I hope that we may made up for the delay. So thank you so much for inviting us, for the interest, and for the interesting speeches that you are showing today. So thank you.
Grazie dottoressa, grazie per
Thank
questo
you
intervento.
for your speech. And this is about the revolution, brought about a revolution. So we're still talking about scientific research, and you highlighted the clinical trials. They basically envisage the involvement of hospitals and clinics, and in Italy, especially, and in Europe as well, it is a problem to involve public hospitals. It's very bureaucratic. Although there are rules, guidelines to do the trials, the rules are not well known. So thank you for your speech, for your talk, which allowed me to say this thing. Yes, it's absolutely important, vital to say that. Thank you. Let's move on to Daniele Finocchiaro, CEO of the Foundation for Cancer Research, Daniele Finocchiaro. I hope that you hear me well. I'll try to share my screen. Do you see the screen now?
Vediamo te in questo momento. Speriamo di vedere le slide quanto prima. Vediamo. Ecco, vediamo le slide. Grazie.
Now we can see the slides. Thank you. First of all, I would like to apologize. I thought it could be quicker. I shouldn't apologize whenever I start my speech, but I perceive I am a friend of EuroBioTech, which has always been at the forefront as an event and has always brought together different experiences and different disciplines. I apologize for not being in Trieste, but I'll be in Trieste in a couple of days because we also have Trieste Next, a scientific event, and we are partners, so we'll meet again. First of all, we'll talk for 4 minutes about IARC because the foundation, IARC Foundation, is something I've discovered something like 1 year ago, and then move on to my professional career, and then leave you with a reflection on what could be useful in this field. Let's start with a topic which is quite relevant and urgent. The cancer data numbers in Italy are really high, 370,000 tumor cases last year, 130,000 deaths, which means 1,000 people a day get a cancer diagnosis. These figures still classify cancer as the topic, the effort we need to tackle. HARC has been supporting research for 57 years now, and it has allotted 1,780,000 million. It's a figure I didn't know before involving with this foundation, is that ARC is one of the most important independent financer of the research on cancer. Of 140 million a year, we are within the 70% of oncologic research. How are these funds allocated? We have 25,000 volunteers, people supporting IARC. The result is divided among 5,000 researchers, and we have a large number of employees and a research center. We have 70 regional committees throughout Italy that do whatever they can to collect and disseminate science and research. The responsibility I have is that IARC is, together with Caritas, the most recognized brand in Italy, which is the real value of IARC for the local territory. In 2022, I'm going to tell you what IARC did in 2022, supporting 856 training and research projects with 136 million euro, 105,000 researchers pertaining to these projects, 55% of researchers is under 40, and female researchers are also taken into account. We funded young researchers with scholarships. And we're also trying to help and support young people, giving them a first grant as IAC. And with a startup project, we support projects by researchers living abroad to curb the brain drain. Another important aspect is for projects between 5 and 15 years that receive specific grants. Then we have some special projects developed in collaboration with other research centers at a European level. Another aspect is that ARC has a research center, ECON, an oncology foundation. It is an excellence research center employing 40 researchers, which is a real science incubator, basic and translational research institution. We perform excellence activities and we are still investing in it to transform it into a more European excellence center. The process through which we allocate funds is a very strict one based on merit. Nothing new for you. We have 600 international reviewers and a scientific technical committee that flank not only the choice, but also they also verify and assess the projects to see they are fruitful in time. We are happy, we are glad about the pervasivity of the scientific community, because looking at the data of publications between 2008 and 2020, ARC has been ranking first in the field of scientific publications, which means that the majority of the projects funded by IARC have strong scientific relevance and are then published. A couple of words on the collection of funds. In 2021, we collected 171 million euro, 5 per thousand from liberal contributions, then public collection, the mobilization of the Italian community for research, which shows the sensitivity we have on the topic. For each euro we collect, 0.79 euro go towards the collection of funds, and we just divide the expenses and the charges of this collection process. Going towards the end of my speech, I would like to tell you about my personal experience. I started some years ago. I was the president and CEO of the first research enterprise, which is up full-time. I invested in a research group founded by Confindustria between 2016 and 2020. Then I worked in a company, a municipalist company in Verona with a high employment rate, with a lot of politics inside. Then I managed a committee that surveilled the competence center of Tri Veneto with the 9 universities of the area and scientific institutions and over 30 companies. At the moment, I am the chair of the Council of the University of Trento. But why am I telling you all this? not because I want to tell you how old I am, but just to tell you what I've understood over my career. From all these observation points, I've understood some things. The first one is the real spread of Italy is in research through instruments, skills, the ability to form networks and so on. Research has never been at the center of the political agenda. Just look at the election campaign in this period to understand what I'm talking about. I've always understood that research was the passport towards the future, towards sustainability of a system. And I've also personally understood that those who cannot innovate are doomed to failure or to be forgotten. But one of the things that Diego Brava has always underlined is that the communication channels in all these fields I've worked in are totally different one from each other. You struggle to find a common language when you talk about open science. You still encounter difficulties, and research today is a multi-dimensional, multidisciplinary thing, and probably not even university are fully capable of flanking this process. We have very important challenges we need to tackle, and what I have been seeing in ARC within the labs where we've faced huge changes, we see doctors, biologists flanked by mathematicians, the chemistry engineers, and so on, which is very important in terms of critical mass and of the complementarity of the sectors. My last slide, the last thing I've learned. I am in the board of the European Consortium of Innovative Universities, where I've understood one more thing that I failed to understand before, that is how important is the research, but not only as an aim to itself, but the research to meet the real needs of people. And tumors is one of those transversal needs in the planet that ought to deserve a the coming together of the activities of civil society, citizens, and researchers. It's a challenge that ought to be the starting point to get to a solution. This implies that the different stakeholders ought to have a common agenda, ought to have a common language, and ought to meet themselves by thinking of themselves as an international global community. I apologize for not meeting the schedule probably, but I hope I've helped you to reflect on this topic.
Grazie Daniele.
Thank you, Daniele,
Cosa hai portato? A parte il fatto che non
because
abbiamo visto le
well,
slide,
unfortunately, we could not see the slides. We had a technical problem, so we couldn't see them, but we will publish them on our portal so that everyone can see the slides, both the people here and both the people following the event in remote mode. I would like to underline that beyond the research and the industry world, we have volunteers. Volunteers involving the 30,000 people you mentioned and involving 100,000 researchers. Well, only in one single field, that is the research on cancer, gives you an idea of the need we all have, the researchers on the one side and the industry on the other, of volunteers. So an association such as IARC is doing so much with the amount of money and of funds you mentioned, which is a relevant amount at a national level. And what you said more in general from your experience, not last as the president of the University of Trento, I think the only private president of an Italian university, just to stress, underline this thing that comes from the industry, because also universities need a dialogue between the so-called civic society and the academic world. So I would like to thank you even more for this, and also for what you did in Confindustria as the person in charge of research at a national level. Your activities have all been very important, and I thank you. And I thank you because your speech closes the circle as far as the difficulties of what we are doing are concerned. Our vice mayor quoted San Diego. This event was born 7 years ago after a conference in San Diego. So we saw at that time what was happening in the United States, and we said, why can't we do the same in Europe? 20,000 people, where we are not 20,000 people, we're much less, but we are insisting we'll get to that figure through the digital. This was a plenary session, research and innovation. Afterwards, we'll have more sessions on research for innovation with enterprises introducing their products. But now I would like to leave the floor to Franco. We are almost on time, I'd say, to draw a fair summary of what we've heard today. In your role of scientific director, you've been exposed to this world and to these speeches, and what are your first impressions? How do you see what you've heard, and how would you insert what you've heard in the NRRP plan? We will have shared labs, but in order for them to be shared, the international, national, and local scientific communities, and this is why I thank our professor coming from Rijeka, it is very important for me to start. What are your impressions?
My impressions are positive. First of all, I had to leave my comfort zone, and from the technical point of view, I understood many things about the synchrotron and other things, and this is an area in which I'm not competent. But one of the things that is really evident is that there is a way to do research, whether it is in physics or bioengineering or in the energy or strictly speaking biology, biotechnology. The research methods are more or less the same. So these are ideas that must be funded and developed, and all the systems of this kind should combine with the productive fabric of the territory. So the final goal is growth and the development of the national system that is funded, that funds these ideas. And I think that the level is very high, because what I understood in terms of the instruments and the investment and the skills that were expressed here, everything is very high. So there is also a cooperation between the academic world the hospitals, production of pharmaceuticals, and the associations. And the last speech really opened a window on this system. So I hope that I will be up to what we saw and what will be launched, because on the 1st of October we will have to launch all the administrative procedures and all the problems that concern the potential of using hospitals to test drugs. This is connected with the bureaucratic part, which will be one of the biggest hurdles that we have to tackle. As I would stop here because I don't have any specific skills, but I am flattered of participating in this event and being seated at this table. And I hope that along with the National Institute that I represent here, that I hope that I'll be able to tackle the challenges, to be up to the challenges in this field. Everything should be well connected at the international level. Thank you.
Se posso dire, ecco, Franco
ha
evidenziato con il suo
highlighted
intervento come noi dobbiamo
in his
porci
talk
di fronte a queste
how
grandi
we should approach
un messaggio che
these
ci ha dato,
big challenges. This is a
che
message
con
that he gave us
come dire,
with
quando
humbleness.
uno affronta cose complesse,
So when
deve
one
essere
faces
da un lato
complex
sufficientemente umile per
issues,
capire che sta navigando in un
they
terreno
should be
complesso,
humble enough to
e
understand that they
dall'altro,
are
secondo
sailing
me,
through
deve
complex
avere
waters,
determinazione.
and
Quindi noi dobbiamo avere
one should also be determined.
e l'OGS deve avere la determinazione di
OGS
completare, se
need to
volete,
be
no? Con 20
determined
milioni di euro
to complete with about 20 million euros over a period of 3 years this innovation hub of the city, of the region, and I would say the Western Balkans, because Trieste becomes a point of reference and a model. So next year, we will see which steps forward we would have made. So we will put other 20 million over the next 3 years, in addition to the 300 million allocated by the government. But 300 million is quite a large amount. I think this is very important, and we are putting 6 million per year more if they are well expended, well spent, if they are used if to make labs, not only for local researchers, but also coming from the neighboring territories. I think that this will be money well spent. This is a public-private partnership. I hope that the private partners will be very careful with expenses, like all the private entities are. This is the contribution that we can receive from private entities. I just wanted to add one last thing. This is not one of the reasons why we obtained this allocation. The reason lies in the strength of the project, but OGS, when it received even extraordinary funds in the framework of even public projects, OGS has always allocated the funds well. We are talking about the boat Arabasi, for example. It is the naval economy that is suffering with the Wärtsilä problem now. With it was a small contribution. So while you originally come from Istria, And I come partially from Friuli and partially from Istria, so I know how careful you need to be how careful you need to be with the public money, public funds. You need to put everything together and be careful in the investment and the allocation, not to waste the funds. We only have a 5-minute coffee break, not 10 minutes, just 5 minutes. So let's try to have some rest in the next 5 minutes. Thank you, everyone.